This week on BSD Now, we're going to be chatting with Antti Kantee from the NetBSD project about a crazy little thing called rump kernels. What the heck is that? And don't worry, he's going to explain everything. We're also going to be showing you all the different cool things you can do with BSD and running a Tor network node or exit node, and just a whole bunch of stuff related to that, as well as discussing all the latest news. So sit back, relax, enjoy BSD Now, the place to be, SD. BSD Now, Episode 8, October 23rd, 2013. Hi, folks. I'm your host, Chris Moore.
And I'm Alan Jude.
And we got a great show coming for you guys today. We got an interview with Antti Kantee from the NetBSD project. Really cool stuff there. But first, we're going to get right into this week's headlines for you guys. So first up, we have the FreeBSD July through September 2013 status report has come out.
Yeah.
Let's see, what do we got here in this status report, Al?
Huge.
We got a lot of updates.
There's reports from all the teams, so the core team, ports team, postmaster team, release engineering, etc. The static code analysis project, and then all the improvements in the kernel that have gone in over the last couple of months, or things that are planned to go in very soon. Architecture support, new platforms that are supported, and new features on those platforms. Userland improvements like Capsicum. Ports, documentation, Google Summer of Code, all of that stuff.
Yeah, that's pretty cool. It looks like there's some stuff here for AES-NI improvements for Jelly, which is pretty slick. Of course, Capsicum, if you guys aren't familiar with what Capsicum is, that's a cool new security infrastructure that's gone into FreeBSD. And looks like NewCons is still being continued. We'll definitely need that as we get more and more KMS drivers in the tree. Let's see here. Download manager for the ports collection. FreeBSD on EC2 news. So yeah, it looks like just a little bit of everything here. So as usual, we're going to post the link after the show in the show notes where you'll be able to take a look and start reading through the full page and get all the gory details. So what's next up?
Just some highlights on that. The AES-NI support, we talked a little bit about that and the speed improvement it provides for Gelly, but all of that is now available in the Open Crypto framework. So any application that uses the crypto driver now has access to that speed improvement. So it's not just for Gelly anymore. Yeah, there's some changes with new system calls called close on exec that make sure that when you fork something, it deals with that securely. But some of the cool things with Capsicum is, the basic idea of Capsicum is you assign capabilities to an application, and once it's done, it can drop those capabilities so that it won't have the ability to do that anymore. So for example, TCP dump needs the ability to open the raw interface, but once it's done that, it can drop all the root privileges it has, so that if a packet comes in that causes an exploit or something, what the TCP dump binary is allowed to do is very restricted, so that the exploit can't go on with whatever it wants.
To be clear, this is more than just setting the capabilities at runtime. This is actually in the code. You can say, okay, I'm going to do something dangerous here, like we'll do decompression of bzip or something. And we can drop privileges at that one specific section of the code.
Or say, I'm done doing the important thing now, so I never need this privilege anymore, and things like that.
I know they had talked about, I guess at one point they had converted Chromium over to using Capsicum, which is pretty cool because they could compartmentalize all the different parts of the browser and say, okay, JPEG, you only have access to this portion of the screen, nothing else. I mean, just some neat stuff.
And so what they're working on now is this project called Casper that will provide a framework for doing things like DNS lookups and other stuff, and it'll be integrated into libc. So that looks really interesting.
Oh, yeah, very cool. So I assume all the details from that are still in the article?
Including open tasks, which are things they still have to do and what's not done yet, which is also just as important as what's ready now as what doesn't work yet. And it's also open to anyone that wants to help with that particular thing.
Okay. Well, very cool. Go read that article if you guys want to stay up to date on what's going on in FreeBSD land.
It's just a giant summary of all the work that's been done over the last 3 months. There are also 2 separate reports that will be out soon from the developer summits from Cambridge and Malta that will also have lots of interesting things on what happened. Because I know, especially at Cambridge, the number of commits per hour during the Cambridge Dev Summit was like 4 times the usual rate.
That's what I like to see when they have dev summits. They're actually getting work done and fixing some long-standing problems or improving things.
Part of it, I think, is just people have code that just needs review, so they bring it to dev summit and you know, they work out the last little errors or whatever. But
yep, very cool. Okay, well, next up we have something in the news here about Dragonfly with SMP contention updates. Go ahead and tell us what that's all about.
So they've made a bunch of changes so that on a multiprocessor system or a multi-core system, there'll be a lot less, you know, one process waiting for another thing to finish before it can continue, kind of thing. Specifically, the name cache had a shared lock that has been removed so that if you're looking up different paths in the file system concurrently, they're not contending with each other for this lock in order to look stuff up. They've also made a bunch of changes to the file system syncer. So that's the thing that when you make an asynchronous write, saying write this data, but I don't need to ensure that it's not a database entry or something where I have to make sure it gets to the disk right away. So there's a background process that eventually writes those asynchronous things out to disk. And the sync command will let you force that to happen at any time if you're about to do something and don't want to risk having data in flight. So they made a bunch of changes so that is much more efficient now.
That's cool. And it looks like here the lead developer mentioned something about they're using Podria and noticed a performance difference with it.
Yeah. Specifically, when they made the change to the name cache code, the bulk ports build they did with Poudrier on their 48-core machine now manages to get the load average up to 300. Of those 300 running processes, 295 of them are in the run state, and only 5 of them are contending for a lock.
Oh, okay, that's pretty cool.
And all that happens with almost no interprocessor communications between the different CPUs. So they don't really have any stats on what it looked like before they did this, but that definitely sounds like a large improvement. That's 300 processes that are only waiting on CPU time, not on locks to get access to some object to continue.
Oh, that's cool. I'd be curious to see if somebody could post some stats on that at some point.
It would be interesting.
Maybe compare it to FreeBSD, see how Podre does there as well. Well, very cool. Next up, we got FreeBSD gets some first boot rc.d scripts. Yep. So this is something that Colin Percival from the FreeBSD project has added recently. Yep. So I guess what he's done, Alan, is set up some scripts that you can tag and say this is only a first-time boot situation right after you freshly installed.
It implements the framework so that you can make your own rc.d scripts so that the first time a machine boots, it can do things like download and install update. So you can have it run FreeBSD-update as soon as the machine comes up.
Yep.
Very important if you're building a cloud image where every virtual machine you spin up for the next 6 months is going to be this image, having it run the update on the very first boot means that it'll have all of the newer bits, right? So if there's a patch, the machine will patch itself the minute it comes up. You can also have it download and install packages, especially now with package.ng actually being usable. You can say, hey, when this machine boots, install these 10 packages I need or whatever.
Sure. This actually looks like something I'll probably try using in pc-bsd land. We've already had to do various scripts and flags to say at first boot, let's run the display wizard, let's run the first time setup
wizard.
And
you have almost the same system, right? This Sentinel file that... So basically you create this file called /firstboot, and if it exists, it'll run all these first boot scripts. And you can also create a second file. The names are configurable, but first boot-reboot says after you finish running all the first boot scripts, reboot the machine again, which is important if you're installing a kernel update or something.
Sure. Yeah, this is actually really cool. I'm definitely going to be looking into pulling this in if I can.
Some of the other cool things are if you're doing cross-architecture installs. So if you're building images that are going to get deployed on an ARM machine, you can't necessarily install packages on the image before you deploy it. And so being able to do some of the stuff that has to happen on the remote architecture on the first boot solves a lot of problems. Also, if you're building firmware images like the 4 gigabit image that you put on an SD card and load it into your pfSense box or whatever, you can have it resize the file systems the first time it boots and then reboot, so that you don't get those errors with the other stuff. Or the use case that Colin actually had, it's funny it's listed as the last use case, but for EC2, have it on the first boot do things like pull in the SSH key for the user and set it up, and all the setup you have to do for an Amazon cloud server.
Well, this just looks really handy. I mean, it's a script, which means we can script it to do just about anything. So this is cool that it's finally hit FreeBSD, and it's already been MFC'd to 10 stable and 9 stable as well. And they added a port, I believe, just the other
so there's
day.
a port for older versions as well, since most people are probably going to be running 9.2 release on their EC2s, not 10 stable.
Sure.
Because it's like 5 lines that go in your RC script, so it's not
piece of cake.
so there wasn't much to worry about as far as the MFC goes. And then I actually came up with another use case for it just today. Someone was mentioning about the ZFS boot change I made to the FreeBSD installer doesn't set the var empty to read only, because if you do it too soon, then when you do the extract of the base, when it tries to create that directory, it fails and it blocks the whole install. And so because we want to be able to repeat it during the installer, we don't set that bit. But if we could add a line to make it set that the first time you boot the machine, that would solve that problem in a safer way.
Yeah, that's very cool.
So it might actually get used pretty quickly there.
Yeah, that's pretty slick. Okay, well, next up here, we got some NetBSD news. They got Lua scripting in the kernel. So that's pretty cool. So what's that all about?
I don't know.
You don't know?
Basically,
somebody wanted it.
They want to make it a little more approachable for people to actually build stuff and functionality into the NetBSD kernel, and they realize that not everybody is a C programmer or whatever. So they're like, if we had this reasonably useful scripting language that would let you, basically, it provides this device driver and a user lane control program for running these scripts as part of the kernel.
That's actually something I'm really jealous. I would really like to see that in FreeBSD land, because I'm not a kernel developer, but being able to script something out and then run it that just sounds really cool.
Yeah.
I'm kind of jealous of you guys.
Their commit messages don't really say much about what it is. It's like, welcome the Lua device driver, and that creates a control state for Lua inside the kernel. I'm like, I like compare that to Colin's commit message, where it's like, here's 5 use cases of why you would care about this.
Yep. The actual commit message is longer.
Yeah, and then in theirs, the commit message mostly consists of a list of the files that are modified, which is kind of provided by the commit system anyway.
Maybe that's something we can get a NetBSD developer to come on the show at some point and kind of tell us about and how it works and why you'd want to use it and all that. But I can imagine some neat use cases for it. It sounds pretty cool.
Yep.
Oh, okay. Well, very, very cool. Well, next up, actually, since we're on the topic of NetBSD, that's going to kind of lead us into our interview we did this week. So next up, we have our interview with NetBSD developer Antti Kantee. And he's going to be talking about some of the cool features of the any kernel and rump kernel work that he's involved with. And don't worry, he'll explain what that is here in a moment. So sit back, and I hope you guys enjoy the interview. This week, we're joined by Antti Kantee, a NetBSD developer. Welcome to the show.
Thanks for having me.
Yes, thanks for being here.
Okay, so first up, go ahead and give us a little bit of background about yourself, how you got involved with BSD or NetBSD specifically. Kind of walk us through the process here.
Yeah, so back in the 90s, when like every other good schoolboy in Finland, I was running Linux on my machine, and it was Slackware back then. And I didn't know anything about package management, so everything you did, you just got the sources and compiled it yourself and installed it, and things were going pretty well. And then what happened was that GCC 2.8 came out, and then of course, new compiler must have.
Yes.
So downloaded it, compiled it, installed it, things were fine. Then I made the mistake of recompiling my Linux kernel with GCC 2.8. And what happened, there was a weird interaction that if you compiled a Linux kernel with GCC 2.8 for a while, X Windows broke. So that got me thinking, maybe I could try some other systems which are out there. And tried a few, and at the time NetBSD was the only one which didn't have any obvious flaws. So the only thing I remember back then was when I started playing audio on my NetBSD machine, it always printed in the kernel log printer out of paper. So that was the only obvious flaw with NetBSD, but it turned out just to be an IRQ conflict. And that's really how I got stuck on the NetBSD track, and eventually became a developer. So I don't know, I maybe like to say that I've been a developer since the 90s. The truth is I've been a developer since the latter half of December 1999, but it counts as the 90s.
Yes.
So that's how I got started with NetBSD.
Okay.
Oh, very cool.
So the main focus of our interview today is any kernels and rump kernels. Could you give us a brief description of what those two things are?
Yeah, so, or I'll attempt a brief description. So I guess if I give a full description, it'll take the better half of next week. But the main idea is that you should be able to run kernel drivers anywhere. And, okay, so...
Explain, what does that mean?
Yeah. I'm trying to explain briefly. So... well, okay, let's walk through the concept. So the any kernel is essentially just a play on words. So operating systems are, this is a monolithic operating system, this is a microkernel system, this is an exokernel system. And what all of that means on a fundamental level is how you arrange drivers with respect to applications. So, in a monolithic kernel, everything gets lumped up in the kernel. In a microkernel, in a multi-server microkernel, they might be in different servers, and then you route requests somehow to and from them. In an exokernel, it's kind of the application and the kernel drivers are in one package, and all of these have their advantages and disadvantages. And my view is that none of these approaches is correct. All of them are correct. So if you look at the structure of an operating system kernel these days, there's capability to run processes, there's scheduling, some virtual memory support, but then you have millions and millions of lines of drivers. And you have to author these drivers for each system individually. And then if they are tied to that environment. And what the any kernel is just saying is that you should author your system in a fashion where you can run your drivers in any environment. Now, maybe that sounds like science fiction, but there's actually a working implementation in NetBSD for this. Now, that was the first concept, the any kernel. It's just a concept. The second concept is the rump kernel. So when you have a driver essentially being what I tend to call a protocol translator. So a driver takes some input like, read this file or this offset of this file, and then it processes it. Okay, on this file system format, that means those blocks on the disk and does things like this. There's TCP/IP driver, there's the obvious device drivers and so forth. I think system call handlers are drivers because they take parameters and know how to process them. But anyway, like to make the any kernel work, the drivers, in addition to doing this protocol translation, which is what their main work is they need to they need some support for doing this. Like, let's say they need to be able to allocate memory. They need to be able to do synchronization. They need to be able to do things like that. And when you have an any kernel and you want to run your device driver out of a monolithic kernel, you need this support functionality. And that's where the rump kernel comes in. So if you look at in the dictionary for the word rump, there's a bunch of definitions. You need to, well, admittedly, I didn't check all of them before I picked the name. But if you pick the right one, it's like part of a whole or a part of something which really isn't the whole something. And that's what the rump kernel does. It provides enough support to be able to run drivers, but it doesn't provide anything else. So you cannot run processes in a rump kernel. It does not do virtual memory. It does not do scheduling. And these features are what make rump kernels highly portable. So in effect, you can run the device driver or all of the drivers from any kernel pretty much anywhere. So in user space on many operating systems, I've run the NetBSD kernel drivers in user space on Linux, FreeBSD, Windows, Solaris. You can run rump kernels in a web browser. You can I've run rump kernels inside the Linux kernel. So you have unmodified NetBSD kernel drivers running inside the Linux kernel. And I don't know, on top of the Zen hypervisor, I've done that. So basically the fundamental requirements that a device driver has are so minimal that you can run them anywhere.
So
that was my brief explanation.
Could you turn that around and use an unmodified Linux driver on NetBSD?
Yes, but you would have to turn Linux into an any kernel first. And I actually did some prototyping work for that about 5 years ago. It took a week or two of work to make one of the Linux file system drivers run in user space on NetBSD.
So where did you guys come up with this idea? Is this something you came up with, or when was this first proposed?
Right. So like everything, there's a story attached. So about 7-8 years ago, I was working on a user space file system framework called Puffs. And I was really enjoying the part of developing file system drivers in user space. But the problem that brought was that, okay, well, there's a certain set of file system drivers you can implement in user space, but then we have this whole other set of file system drivers which are implemented in the kernel, you know, like FFS, NFS, whatever. And having a user space file system framework did not address that problem. So if I wanted to debug or develop the FFS driver, I still had to do it the old-fashioned way by using a virtual machine or whatever. So kind of started looking into how complicated would it be to make the unmodified kernel FFS driver run in user space. And, you know, turns out it wasn't that complicated. It took, I think, a week or two to hack it up. You know, there were a lot of hacks, but the bottom line was that the completely unmodified driver worked in user space. And then, you know, okay, here we have one driver working in user space. Let's try this other file system driver. I can't actually remember which one was next. It was something like, one of the kernel file system drivers. And turns out it you know, needed approximately the same type of approaches. So, you know, then you kept adding file system driver, and then eventually most of them ran in user space unmodified. And then you start thinking that, okay, now you have this hacky version of malloc and synchronization and VFS and all of that running in user space. So what if someone changes these parts in the kernel? Like, then obviously the user space framework would need similar adjustment. So, you know, kept adding, okay, could I run the whole VFS layer unmodified in user space. And then, okay, I'd like to run NFS, so I need networking for that. And, eventually it was a kind of a cycle, add support for this, figure out how to do it properly, add support for this, figure out how to do it properly. And, 6-7 years later, here we are.
That's quite a bit of stuff.
Yeah.
Yeah, and quite a bit of time.
So are there any security advantages to running software using this system?
Yeah, so I mean, if you think about the whole idea of a microkernel, it's isolating drivers into separate containers, and this can, or a rump kernel can provide essentially the same benefit. So a very good example of this is file system drivers. So there's a very long-standing problem that file system drivers aren't usually very robust if your image is corrupt. If you look at, for example, the BSD or Linux manual page for mount, they both contain exactly the same text, which is something like a corrupt file system can cause a system crash.
Which I'm guessing is left over from a very long time ago, and that's why it appears identically in both man pages.
Yeah. And I'm guessing because it was written such a long time ago, you didn't have the same problems as you have these days. You didn't have people, hey, let me give you my file system image on this 2-ton hard drive. Can you plug this into your system? No, you just had a file system and it was a trusted image and you used that. But of course, with things like floppy disks, USB sticks, CDs, things like that, someone can slip you a malicious image very easily.
Sure.
So how I came to realize this was, I remember a long time ago, someone posted on the NetBSD list that, hey, I have this MS-DOS file system image, which if I mount it, my kernel panics. So, I took a look at it. Mounted it in a rump kernel. It was very easy to single step it and fix it. But then I got thinking, if this happens accidentally, what are the odds that someone could create a malicious image which specifically targeted a vulnerability in your file system driver? And I don't know, for example, at conferences where they distribute everything on USB sticks, like someone slips a malicious image there and everyone mounts it happily using an in-kernel file system driver, and boom, bad things happen. So there's, with the combination of rump kernels and the user space file system framework puffs, you can just, with a simple flag, isolate. If you mount from an untrusted source, you can isolate it into user space. And of course, the advantage the any kernel provides over for example, a microkernel system is that you don't pay this kind of separation penalty for all of your file systems. So your root file system is obviously trusted and not malicious. So you don't need to mount that in a separate domain. But when you have these risks, you can compartmentalize them. So this was well summarized by Todd McQuillan once, who said that what happens in user space stays in user space.
That's right. So would you classify this maybe as like a lightweight alternative to kind of virtualization, or is this a totally different use case?
Well, it's kind of a bit of both. It really depends on what you mean by virtualization. So if you mean the normal use case of virtualization, where you provide an application, a kind of environment to run applications in, well, like I said, rump kernels they're about device driver or just kernel driver virtualization. So it's not applicable to that use case. But for example, you can view like you can, for example, have 100 disjoint virtualized copies of the TCP/IP stack driver this way. So in that sense, it is it is a alternative, lightweight alternative to virtualization, but on the other hand, you can't run applications in it. So in that way, it isn't.
So obviously, with running things in user space, there's issues with overhead. Do you know about how much there is, or what it's like?
Yeah. So well, first of all, user space is only one environment you can run rump kernels in, and the overhead question is kind of tricky anyway, since it's not really inherent to rump kernels per se. So, for example, if we use the exokernel model where the application and the driver are in the same package, in the same address space, in that case, a system call is about twice as fast as a regular system call. So in that case, you could say you have minus 100% overhead.
Right.
But of course, that's not the entire truth. So it really, like, kind of overhead really depends on what you're doing. But there's a few, I think, critical numbers. One is how much memory is used by a rump kernel, which essentially dictates, first of all, how much you can scale or how much you can virtualize. Like if you want 100 copies of the TCP/IP stack. I mean, if you're doing, for example, network testing,
Sure.
you want 100 copies, you want 1,000 copies. There's a slight difference if you need 10 megabytes per image or 5 megabytes per image versus 50 megabytes.
Especially when you're multiplying it by 1,000.
Yeah, right. It starts adding up. And for that, the overhead of a rump kernel is some megabytes, so some megabytes per instance. Of course, if you want to use a gigabyte of network buffers, then there's no magic which will save you from that. But assuming each virtualized instance doesn't really do much, then it's a few megabytes. And the other important overhead figure is bootstrap time. So how long does it take to start a rump kernel?
Right.
And for that, my goal has been to keep it under 100 milliseconds, because that's pretty much the delay that humans can perceive. So the idea is that you can run a rump kernel as part of a command line utility, and no one will notice that, hey, you booted a virtual kernel.
Right.
Oh, that's cool. Well, kind of changing track a little bit here, we have this cool link in our show notes about running a rump kernel in JavaScript. How does this work? What's this all about?
Yeah, so JavaScript. So, well, first of all, maybe I should say that, you often see links these days which say Linux running in the web browser. And how they do it is that they have a machine emulator written in JavaScript, and then they run something like x86 Linux or whatever.
Sure.
But here, like I said in the beginning, the kind of requirement or the platform requirements for running rump kernels are so low that one day about a year ago, we were chatting about what could be done in JavaScript, and there's this idea that JavaScript is a machine language. So I thought, well, maybe I could try running kernel drivers. I'll just compile them to JavaScript. Went to a search engine and see to JavaScript compiler and found one, and then started compiling it, and well, eventually I had a demo which I think supports FFS and maybe some other drivers, and it's just what it sounds like. So how the compiler works is it takes LLVM intermediate representation and just turns it into JavaScript. So if you compare the LLVM intermediate representation and the output JavaScript, it's pretty much like you think, okay, this could be done with sed. There's of course a few other things you need to do, but it really looks like that. So it's actually quite amusing to first look at the C source, then the intermediate representation, and then the JavaScript, and see how similar all of them are.
So you also mentioned recent efforts to run rump kernels on the Xen hypervisor. How does that work, and why would someone want to do that?
Yeah, so it kind of, I think, started out as one of these experiments to see how or where you could run rump kernels. But it turns out there's this phenomenon called the cloud out there. And how you usually provision services in a cloud is that you take even if you want just a single application, you take an entire operating system and make an image and throw it on some service and then run your application in the operating system. But that's kind of wasteful if you just want to run one application, a single application per
instance.
Yeah, per instance. And I think the reason why this is done is because there's currently no other sensible way to do it. So, okay, let's say you have a web browser or you have a database or whatever. So, of course, they run on top of libraries, which run on top of system calls, which do all kinds of tricks. You have TCP/IP provided by the operating system. You have file system drivers provided by the operating system. All of this stuff. And so I just started looking at what if you could just run rump kernels directly on the hypervisor, so without any intermediate OS, like the overhead figures we discussed earlier could lead to significant savings. You could provision 10 times as many applications. And turns out it was about it's about 1,000 lines of code to write the necessary hypercall implementations to make rump kernels run on top of the Xen Mini OS, which is not a full OS, but it's I don't know, I'd call it a firmware.
Right.
So after this, I was contacted by Justin Cormack, who was working on an interesting project involving LuaJIT, and he wanted to run the LuaJIT interpreter directly on top of Xen. And he said, okay, well, now you have these kind of rump kernels provide the system calls, but applications tend to run on libraries, so we need libc, we need libm, all of that stuff. And then eventually, sometime later, we had, Xen hypervisor, mini OS, rump kernels, libc, all the other userland libraries, and then applications, which just boot directly. So you get the Xen guest, which boots directly into an application.
Oh, cool.
Wow, that could be really useful on kind of like when you're doing platform as a service rather than infrastructure as a service. So instead of renting out the whole virtual machine, someone's paying you just to run their app, I can see how that could be very useful.
Yeah, that's definitely cool. So another use you have for rump kernels is the FSUtils, which lets your user space programs access file system images. Can you tell us a little bit about how that works?
Sure. So old-time users probably remember mtools, which was very useful during the floppy disk era when floppy disks didn't actually work very well, so they got corrupted and whatever. So if you mounted the floppy disk with the kernel driver, then it was corrupt. You got the same results as we discussed earlier. Corrupt file system may cause a system crash. So FSUtils was kind of the idea to plug in rump kernels to the standard Unix file utilities like mls, mv, cp, so forth and so forth. So the idea was that first of all, mtools was first of all limited to FAT. So you just had one file system driver, and second of all, it had its own syntax. So combining rump kernels, where you get the kind of file system drivers running in user space for free, and then combining the Unix utilities from NetBSD. You combine these two, you get the standard usage, the standard tools, with the exception that they don't use kernel file system drivers. They use drivers running in user space, and this also makes the whole approach portable. So I've used FS utils to access file system images on, I don't know, Linux, Solaris. I even used it on Windows to access NFS shares.
Oh, neat.
That's useful as well. So how does the NetBSD project itself make use of rump kernels?
Yeah, so I'd say the main, well, I can't speak what each and individual developer does with them, but the project-wide use is testing the system. So we have this continuous automated testing, which is run, I don't know, on different architectures n times a day. But now the problem with kernel testing is that if you have a slightly experimental feature or something which is known not to currently work, doing something causes a kernel panic. If you just try to execute that test against the test host, your testing stops pretty quickly. Yeah. So by isolating all of the kernel driver testing in rump kernels, you just get a series of results like, this driver caused a kernel panic, this driver failed in this way, whatever, and it doesn't affect the entire test run.
Right, it kind of fails gracefully.
Yeah,
the way it should.
Yeah, so there's pretty much no difference between a failing test and a passing test in terms of the test framework.
Right, the effect on the machine running the test.
The host, yeah.
Yeah.
It's very cool. Okay, so last up here, how can people get involved and start playing with this if this is something that strikes their curiosity?
Well, I mean, I've tried to make these things really easy to use. So for the past year or so, I've been working on various projects on GitHub. And for example, if you're interested in trying this stuff out in your on your operating system user space, all you need to do is clone a repository and run one script, and it'll fetch the NetBSD kernel sources for you. It'll compile them, and then it'll run a series of simple tests. And for example, for the Zen thing we talked about earlier, there's a similar repository. So there's just one script. You clone the repository, you run a script, and then there's a small demo. So it creates an image which boots into a web server, and you can start playing that way.
Yeah.
So yeah, I don't know. Maybe you can provide additional links in the show.
Yep.
Definitely. Well, very cool. Any other questions, Alan?
No, I think that's a
great interview
for that. It seems like a really interesting feature, and especially the running a bare application directly on Zen seems, instead of doing a virtual server, somebody just needs to run a certain application. That could be, you could triple the density you can get in each host server.
Yeah, definitely some very cool stuff. All right, well, we thank you so much for joining us today for this interview, and hope the community looks forward to seeing this in a future date.
Thank you very much.
Okay, in our tutorial today, we're going to be talking about the Tor network. In a few words, it's basically a way to anonymize your internet traffic. It relies on volunteers to donate bandwidth, and the more people who run relays, the faster the network's going to be for everyone. All the BSDs make an excellent choice for Tor, and you can even get a free t-shirt, which Alan will tell us more about later. But first up, this tutorial is going to show you how to set up your BSD system as either a relay, a bridge, an exit node, or a hidden service. Alan's going to tell us a little bit about what each of those terms mean, and he's going to be using FreeBSD for the installation in this case, but the majority of the steps are pretty generic, and you can run it on OpenNet or any other BSD. Running an exit node comes with its own set of legalities, so you should carefully read all the links in the tutorial before you decide to enable that. Relays, bridges, and hidden services pose no legal threat to you since they're just passing around encrypted traffic to other nodes. Well, Tor does have a pretty good security record. I don't want to take any chances on this, so we're going to be running ours in a jail. So, Alan, go ahead and take it away. Show us how we set this up.
So, a relay is a system running the Tor software that basically just relays packets between different nodes, right? So, the idea with the Tor network is that the traffic comes in, it gets routed around, pings off across a bunch of different machines, and then eventually gets to an exit node and goes out to the internet. And so because each node only knows where it came from and where it went next, you don't know what 2 hops ago was. And so no one node knows where the traffic came from or where it actually left the network.
Very cool.
And so unless your traffic goes through multiple relays, then it's not really secure. So you want to make sure it goes through a lot of relays. And so the first configuration we're going to show you how to do is a relay. So after we install Tor, we have to make a config file for it. So we'll just make a Tor RC file, and we have to set the port that you want the relay to run on. You can set a name for your relay node. You can make rules about how much bandwidth it can have and things like that. In this case, we'll set it up with, say it can have 1 megabit of, or 1 megabyte per second of internet traffic. This will depend on your connection and how you're setting that up. And then we'll set our exit policy to reject all traffic so that our Tor instance here is not used as an exit node. Then we want to set Tor up to, start at boot time. So we'll just Tor enable to our rc.conf. And now if we do service Tor start, it starts up and starts listening. And if we look at the log file, we can say it's starting to synchronize and learn about usable directory servers and so on. And, if you run a relay for a couple of months uptime and an average of 500 kilobytes per second of traffic, you can get a free t-shirt from the Tor project. So there's some incentive to actually do this now.
Sure. Now, would this set you up so that on your local machine you're now able to navigate or browse via the Tor network, or is it
the Tor client? Yes. So this sets up a SOCKS proxy on one of the other ports, and you can point your browser at that, and it'll proxy your browser's traffic through this Tor node.
Very nice. Okay.
So one of the
I'm just thinking out loud, so I could set this up on one box on the network and then proxy all my browsers to that.
Or you can. We don't have a tutorial on that, but there's a more complicated configuration where you can actually, set up use the Tor machine as your default gateway and route traffic that's not a proxy, that doesn't understand proxying through it, and so on.
Oh, very nice. Okay.
One of the other configurations you can do is what's called a bridge. Which is an unlisted relay that lets normal people get to the regular relays. So specifically, bridges aren't published. There's no list of bridges. And the purpose is to help people in restricted countries like China, which are actually filtering and blocking traffic going to known Tor relays. So they'll connect to your machine that looks like a regular machine, and then you let them connect to a relay. So you're basically an unlisted relay so that when all relays are blocked for this person, they can still get to you to connect. Running a bridge uses much less bandwidth because you're only somebody's original introduction to the network. Not, there's not as much network traffic flowing through you. And it's fine to run on your home connection because it's untraceable, right? So it's not going to be like an exit node or anything like that. So for that, the configuration is fairly simple. You don't have to limit your bandwidth, and you basically set the SOCKS port to 0. So it'll disable that local SOCKS proxy so that, the one normally set up for you to route your browsing. And then we just say, make this a bridge relay. And now when we start Tor again, it's a bridge.
Yeah, that was too simple.
Now, an exit server is a little more complicated.
Let's put the big disclaimer on this at the beginning right now.
Where'd that go? So exit nodes are where that traffic actually leaves the Tor node or Tor network. So it gets decrypted and sent out onto the real internet. Without exit nodes, no one could access anything except for stuff that only lives inside Tor, called hidden services. But in order for people using Tor to get out to the real internet, they need exit nodes. So they're very important, and there can never be enough of them. The problem is that a lot of people are using Tor to do illegal things. And running an exit node means that all of that malicious traffic or traffic doing illegal things or whatever will be coming to the internet from your IP address if you're the exit node. And you may be subject to erroneous police investigations, right? Somebody uses the Tor network to hack into somebody's bank account or something. The bank traces the IP back to you, and the police show up at your house, even though it wasn't you.
Sure.
So there are many helpful tips on running one safely and legally. 9 times out of 10, you just need to explain what Tor is and what it does, and it kind of shows that it wasn't you. But the FBI is lightening up on their aggressive behavior towards people running exit nodes, but
so I haven't really heard anything about this, but are ISPs also cracking down on that? In other words, if I run an exit node on my home connection, is Charter going to be like, why are you guys pirating movies and doing whatever from my home connection?
Especially if you're in
will
like
they
a
shut
three
me down?
strikes country, where when that happens, you get your internet shut off.
Yeah. So
So
I would imagine you'll need to be careful on especially.
So
on your
the
home
Tor
connection.
wiki has many useful hints on running an exit node. And as the exit node, you could also set a bunch of different policies. So if we look at making one here, we have to get rid of the bridge thing and put back in the relay stuff. But the biggest thing is that you can control what ports people can use. So, if we just look at something like this, so we'll get rid of our policy to reject, and we'll say, accept traffic going out to certain ports. So you can block certain things and say, I only want traffic on HTTP and HTTPS. I don't want to allow people to use IRC routed through my connection. Right? Because on a lot of IRC networks, Tor exit nodes are banned because people use Tor to evade regular bans or just to spam or otherwise be abusive. So a lot of IRC networks don't allow Tor. So if you want to be able to IRC off your IP, you might not want to allow Tor to also IRC off your IP.
Sure.
And things like, so in the tutorial, we have a bunch of different ports defined, kind of give you an idea of what a typical configuration might look like.
Out of curiosity, does it get any more fine grained where you can say these are the whitelisted maybe IPs or websites or something you can get to?
The first field there is the destination, and the second is the port number. I think I don't know how that works with the Tor protocol of if you announce your whole list of what you allow and then only that traffic gets to you or what. I'm not that familiar with.
Or just bounces along if it comes to you and says, "Oh, I can't get out
it
here"
just
or something.
keeps going or something. I'm not sure. So
Interesting.
this is what's called a reduced exit policy, and it lets people. It helps prevent people from running BitTorrent and other things that might get you DMCA requests. Not so you're only allowing certain ports. It won't cause as much annoyance to you, and so you can choose what goes out and what doesn't. Also, if you're going to be running an exit node, there's a couple of Tor mailing lists that you should probably sign up for so that you get any news that would be of interest to people running Tor exit nodes. And we have a bunch of links like that in the show notes. The last thing we have here is what's called a hidden service. It's basically a server with a hidden IP address. So a hidden service can't be accessed from the internet. The only way to get to a hidden service is by connecting through the Tor network. So it's a way to run a website or a server or something that can only be accessed through Tor, never from the public internet. So you can run a website, an IRC network, an FTP archive, or whatever you want to run. And you'll need to be careful in configuring it because you don't want it to ever make an outbound connection over the internet, because that'll give away what the IP address of this server actually is. And generally the idea of running a hidden service is that people don't know where it is on the real internet. So, while Tor provides all this ability to hide, if you configure it wrong, it doesn't help at all.
Sure.
Right? So you don't want the real address to be leaked at any point, whether that's just a message on the service or it making an outbound connection or anything like that. For example, if you want to run a website and mirror something or whatever, and install Tor, so what we'll do is we'll make a new user called Tor guy. We'll make it so the Tor service owns that home directory. And now if we edit that tor.rc file again, then all we need to do is set up our hidden service directory and port. And basically what this means is on the Tor network, it will expose port 80. And when a connection comes in, it'll actually proxy that to localhost port 80, which is where you'd run your regular web server.
Okay.
And it's pretty much ready to go. And now people can anonymously access that web server. And whatever you're running there. You'd have to set up Nginx or whatever you want to run there.
Is there a way to set a policy like how many bounces it has to make before it can get out in order to protect yourself?
The way Tor works is no one can predict how many bounces it took.
Okay.
So when you set this up, Tor will create 2 files in that new home directory. It's supposed to anyway. Oh, I have to start Tor. Yeah, so we have the host name and the private key files. And the host name will basically be what the .onion address is. So this is the address that people on the Tor network use to find you. It's basically just a fingerprint. In this case, it's a bunch of random letters, .onion. And that's now the host name of your hidden service. And only people using Tor can connect to that address. And basically, the Tor system has its own top-level domain DNS service that resolves those .onion addresses to the Tor addresses. And now,
very cool.
You're ready to go.
Okay, so you showed us all the different types you can run there. Well, thank you very much, Alan. So as kind of a little outro to that, the Tor network needs all the help it can get to fight against censorship and defend privacy. So running any kind of node is going to be a big help to them. And we're also going to have a link in the show notes to a BSD-specific Tor mailing list, which you can join if you'd like to get some more details about using it specifically on BSD. So that was an awesome tutorial. Thank you very much, Alan. Next up, we're going to get to our weekly news roundup. Just really quick run through some of the highlights over the past week in BSD. So first up is something we're actually doing in the pc-bsd project, just a weekly feature digest that we're going to start posting usually every Friday evening. And it's just going to tell you about new features or bug fixes, things that have changed in the tree that week. Just putting kind of a human spin on it as opposed to making you read through Git logs, which is what I know nobody likes doing.
It's what the rest of the
Isn't that how
the rest of the projects make us do, and we distill it down for a show. And so pc-bsd is like, we'll make BSD Now's job easier by giving them a post they can just point to every week.
We'll just give you one weekly post and says, here's the cool stuff. Here's some neat. Yeah. We just want to make it easier for people to keep up to date with the project because everyone knows reading Git logs sucks or SVN logs.
So about that, when are we going to have 10 ISOs?
Okay. Yeah. That was one of the things we announced this last week. So I'm hoping to have them done. If I check the Podre build, it'll probably be done late tonight. And hopefully I'll have an ISO spun up in the morning. And then we'll upload it. I want to have it ready for this weekend. Is the goal.
You're doing another Podre run? Okay.
Yeah. I had to do another one. I had built it with some incorrect flags. We wanted to get the new AMD drivers in there so people can start testing the new video stuff.
And so you have to have all these X flags.
So we put all those in, updated the ports tree, and it's like now we're going to rebuild 13,000 of them because some really big blocker changed or whatever. So anyway, it's finishing up now. Hopefully we'll have an ISO in the morning ready to roll, and then I'll upload it and have it in time for you guys to play with on Saturday. So that's the plan. I'm going to try and bring it out to VBSDCon as well. So if you're going to be attending, I will burn you a disc. If you bring me a blank DVD, we'll set you up and be able to have something to test. So anyway, we'll have more details about that towards the end of the week in the next weekly roundup, I'm sure. And that'll include the new text installer, too, that we've done for PC sys install. So we have a front end to that as well. So just some new stuff to play with. Yep. So what's next up here?
The new one we have is OpenBSD has implemented the VXLAN interface, which is this really cool system for tunneling layer 2 packets, so like Mac Ethernet, like your regular layer 2 stuff, over layer 3. So it allows you to basically extend a LAN or a VLAN over UDP. So this is especially important if you're running a bunch of groups of virtual machines. Part of the problem is if you're using VLANs, there are only 4,000 possible VLANs. If you're doing one VLAN for each customer or each project or something, you can actually run out of VLANs. Whereas VXLANs can go through routers and stuff because it would be UDP instead of layer 2, and you can have they have a 24-bit identifier, so you can have 16 million different VXLANs. And so what this lets you do is have a LAN that extends between different pods or groups of virtual machines. So you can have basically a software-defined data center where you can have machines in different rooms or even different data centers and have them all appear to be on the same LAN by using this VXLAN protocol to route the packets over UDP, even when they're layer 2 packets that aren't routable.
Oh, very cool.
So it allows you to create a cloud system where if you're going to have multiple availability zones like they have in Amazon, where the machines, if you're going to run 2 copies of the virtual machine so that if one goes down, the other still works, you can't have those 2 be on the same physical host or possibly even in the same physical location. But you want those 2 to be on a LAN with each other. So this system allows you to basically extend the LAN between locations using tunneling. And basically before now, the only ways to do this were like VMware's vSphere or this fancy Cisco thing, both of which are rather expensive ways to do it.
Cost prohibitive.
Now you can just use your OpenBSD router and huzzah.
There you go. Yes. That's very cool.
So I hope to see that come to FreeBSD, especially with Beehive getting almost to the point where you can start doing things like this.
Please port that over. Somebody that will need that ASAP, or at least in time
we'll
for 11.
We'll have to poke Rake about that. He'll be at VBSDCon.
Okay, there you go. So next up in the news roundup, we have OpenZFS. They did an office hours this last week. So what is that? That's basically a question and answer session, or they'll get an OpenZFS dev on board.
So they have schedule and they'll post times, and at a predetermined time, I think they're using Google Hangout in this case. I think they're going to try a couple different things and decide what works best. Including I offered to donate the live streaming but they kind of like this multi-way streaming, especially since
Sure,
in this session
sure.
they actually had 2 experts on.
They had Matt Aarons,
Yes,
was
and
in
then
it, right?
the guy in the green shirt second over is, I forget his name, but he's one of the other big ZFS devs. And so you could post your questions a couple of different ways, or join the Google Hangout and ask your question in person, kind of thing. But also the Open ZFS channel on Freenode. So I managed to get one of my questions answered. As
What was your question?
well, we talked a little bit about it at EuroBSDCon, but it was on their list of their to-do list. They talk about expanding the maximum record size from the current 128 kilobytes to 1 megabyte. Hopefully, in a way compatible with the closed source Solaris or Oracle way of doing it. But my question is, can we make that arbitrarily bigger? If you're going to be in there making the changes, what about making it do 4 megabytes or 16 megabytes?
Sure, just extend it out.
In my particular case, chunks of my video files are always pulled in 16 megabyte chunks. So if I could make that the block size, and he explained what the problem with that was mostly doing with kernel memory allocation, is you don't want to, if you have too much fragmentation, you'll use up all the kernel memory space. Most of his understanding about how that works is specific to Illumos, and he's not even sure if the same issue even applies to FreeBSD. Because I think on a 64-bit machine, FreeBSD's kernel space is simulated at like 512 gigabytes or something. So even with a lot of fragmentation, it would take a while to fill that up. So it's,
so this is primarily for other platforms.
They're thinking about ways that they can, even when you're doing a 4 megabyte allocation, allocate it in blocks of 128 kilobytes so that it'll work on all the platforms nicely. 1 megabyte's probably good enough for now. And they figure out how to approach doing it more, especially since the way Linux allocates kernel memory is entirely different.
Yeah. Well, hopefully they'll get our ZFS send and receive resuming support put in here soon. That's what I'm really waiting for.
The amount of traffic that would save me. Nothing worse. I just did one. I replicated 990 gigabytes, and at like 87% it broke. Yeah.
Well, I'm replicating my laptop, right? And when you do it over Wi-Fi in the house, it just one time out of 10 it fails. I'm like, oh great, I got to resync the whole thing.
But when you're paying for the bandwidth, that's an even bigger deal.
For sure. So, next up in the news roundup, we have BSD Magazine. I guess they've released their October issue. So this is a free monthly BSD magazine. You can download it as a PDF at bsdmag.org. So this month, it looks like their topics, they have FreeBSD moving to SVN, which I guess that happened years ago. So
a lot of people, I guess, didn't really hear about it. And a lot of people are still trying to use like CVS up. And then we're like, why doesn't it work? It's like, because... for a while there, we still supported CVS. So basically, the SVN tree would be exported to CVS. And so you could still use all the CVS tools. But those have since been shut down. And I guess a bunch of people weren't aware of that.
So for all you holdouts who have still been using CVS, this is for you. You need to read this and figure out how to switch to SVN.
There's SVN Up, which provides much of the same capabilities of CVS Up. Or there's SVN Lite, if you only want SVN for checking out and not for actually, committing code and so on, or full SVN.
Sure. Okay. Well, very cool. In addition, it looks like they have a BSD programming introduction, which I'm sure will come in handy to any newcomers who want to kind of dip their toe
into programming stuff. There's an article by this guy I've never heard of named Chris Moore.
And what I read, I don't even remember. That was last
Revamping
month, right?
Life Preserver. It's all about your new tool for backing up your laptop using ZFS Send and Resume.
Speaking of ZFS, that's right. So that's going to be basically the front end to our ZFS Send and Receive functionality. I think it has some mention of the mirroring stuff in there as well, how to do it via the command line, which is pretty cool. I've actually got a FreeNAS mini box here, and I've got 4 or 5 desktops and a server all backing up to it with the Life Preserver, and I get daily emails, hey, this is successful, or hey, this failed. It's pretty cool. So that's going to be covered in the magazine. We have, in addition, an article on migrating from Linux to BSD. So if you're one of those BSD curious types and you're like, I wonder what it would take to switch over, you may need to check that out. And then looks like next up, OpenBSD, some of the LTS updates, which we have already covered previously on the show. But if you want to go read about it, definitely pick up a copy of BSD Mag. Okay, so next up, we're going to go into our feedback and questions segment, where we have a couple questions from folks in the audience. So, what's the first one we have from Ben?
Ben asks, he says, first of all, he loves BSD Now podcasts. And he's certainly a lot going on in FreeBSD and all the other BSDs lately, and it's a great way of keeping up with the progress. So he was watching the package-ng tutorial in episode 3, and you said to provide feedback when you're using a package from pc-bsd and you've thought the build options could be better. So he says it might be good if there was a web interface to the pc-bsd package-ng repo that showed what the build options are and provided an obvious place to comment about that. That's kind of interesting. There's a way to see what the build options are with the package command. Once you have a package, I don't know if you have to install it to get that metadata or not, but I think it's -A. Or what is it?
I can make this even easier for him. I mean, we have all our build options are in our Git repo, and you can browse to it. So what I'll do is remind me, Alan. I'll send you guys the link to that at the end of the show, and he's welcome to browse through it, and you guys can comment or even submit patches via GitHub. So if you need something flipped, just submit a pull request, and we might be able to turn that on for you. I know he mentions here something about PHP 5 needing the FPM option. Let's see here. Pardon the typing for a moment. Yeah, we already enabled that a couple weeks back. So it's set. It's built with Apache and FPM.
Well, actually, looking default, the timestamp on this email is October 5th. So.
Oh, okay. Matter of fact, he may have emailed.
Yeah, I think with the feedback emails, you probably saw this email already, but
turned it on. So yeah, it's already on in the repo. But yeah, we'll post the link in the show notes so you can go ahead and see exactly how we build our stuff
and recommend changes to the options for that. That's a good question.
Definitely. Because there's a lot of, I mean, like as he mentioned, PHP, I mean, there's a lot of ports out there where it really should have some different options on by default. And we want to try and make it accessible to everyone out of box. Okay. So hopefully that answers Ben's question. So next up, we have something from Brian here. Says he's been listening to the newest edition. Really is a ridiculously interesting show, which is a really cool way to describe it. Pushing you to finally try some of the BSD action. So he wants to bring up an idea for consideration at the top of each show and in some of the introduction to those being interviewed. It seems a little bit rushed. So we need a little bit more friendly banter is what he's suggesting. I
suppose.
Such as a sentence or two about our previous week or asking how one another is doing. What, do we need to cry during this or anything?
That doesn't make any sense.
So, I mean, we'll definitely, the
I guess
show's
if
new.
If you watch the live stream, you get some more of that.
Yeah, some of it gets edited out. Me and Alan just chit-chat and set up the show and whatnot. So the live feed may be the place for you, Brian, if you want to see a little bit more of that. But we do try and cut it down and make it a little tighter for the show that actually goes up on.
The show's a little long as it is, and people only have so much time to watch it. And so we want to make sure that they're spending their valuable time on information. I don't know. Nobody cares about our personal lives, right?
Yeah. Nobody wants to see Alan and Chris getting caught up over the last week. How was that built? But anyway, we'll definitely, that's always on the live feed though. So if you want to just watch us at 2 p.m. Eastern, I mean, we'll let you see all the gory stuff. Okay, well, hopefully that answered your question. So what's the next
Toby
one we have here from Toby?
Talking about compiling stuff under FreeBSD. So he said he started watching and he started switching some of his machines over to FreeBSD 9.2 from Linux. And there's some software that he uses frequently that he'd love to get running on FreeBSD. One of these is called Pure Data Extended. And he says a bunch of times for Debian or Arch, he submitted a package build file to build the package. And he says when he's trying to build stuff under FreeBSD, he gets errors when he tries to do stuff. And so in that case, it looks like his make file doesn't have a target with the right name. But anyway. And he's wondering if he's missing a dependency or something. He said he's read the Porter's Handbook, but it seems that, that assumes you already kind of know how to build the software and you're just trying to package it into a port. I'd have to look at the specific software he was having trouble with to tell him about that. But
I think that is kind of what the Porter's Handbook assumes. I mean, at this point, you should have a working, buildable piece of software, and all we're doing is turning it into a package.
There's a section in the Porter's Handbook called slow porting, which is actually about, fixing problems where something won't compile. But actually, this email I've responded to personally, and I tried to run his software, and I found the problem was he was in the wrong directory to find the right makefile. Yeah.
But he's also asking if we could maybe set up a tutorial showing BSD noobs the ropes on making your first ports and how to deal with common makers. I think that actually may be an interesting one.
I've done one port, and I kind of struggled through it, so it would actually be a good learning experience for me.
Yeah, I've done maybe a dozen of them now, and every one it seems like is a little bit different. So you're gonna have to take anything we show you with a grain of salt.
It really depends on what you're building. Building software that uses auto tools is kind of done one way, and pulling something off GitHub, there's like a special way to do that.
Yep. And if it has special flags or dependencies, you need to I need to suck in this and set this LD option. So I mean,
and then
it does vary.
And then if you want
to
offer those compile time options, you have to make a bunch of statements for that.
We should be able to show one though, where maybe this is a generic port. This is how you would set options or flags, and at least give you a starting place, so you feel at least comfortable with a little bit of the infrastructure.
Especially since
how does the package plist work?
Since ports is now being used on Dragonfly as well.
Yeah. Okay. Well, that's something we can put in the hopper, hopefully, for a future tutorial. Okay. Also, and so our last question.
Do you do anything with the grub in the ports, or do you just use that?
We have patched and rolled our own, although now it's in sync with what the real version is in the ports tree.
Peter Grehan, that does Beehive, has a patched version of grub EMU to boot Linux in Beehive, and he wants to make it into a port.
Okay. Have him get in touch with me. I have a second grub port, which is in our pc-bsd tree. I haven't committed to the FreeBSD tree yet, but it basically builds all the grub EFI modules. So you can install it alongside the original, and then when you do like a grub make rescue, you'll end up, that's how we build our hybrid ISO that has USB, DVD, and also BIOS and UEFI options.
Cool. So he has a modified one that does a user space loader to load a Linux kernel out of your boot your Beehive machine and then let you boot the Linux in Beehive. I will forward the email to you.
Me because since I've already done the one, it may be similar enough. We can just make
I have a half of a started make file that might be useful to you as well. Because I tried to do it, but I'm really not good at software.
Send it over. That may be something we get in the tree for everyone.
There's the friendly manager that was missing. So problem solved.
Yes. And the EFI one I mentioned, it's in our pc-bsd tree, but I plan on committing it to the FreeBSD tree sometime here in the near future, once I just do a little more testing with it.
So last email, Noah writes, "Hi guys, he just wanted to write, or type as the case may be, to say how much of a kick he's getting out of the show. And he's primarily an OpenBSD guy, but he loves all the coverage and the interviews and stuff. And we've also gotten him over his bitter OpenZFS zealotry and trying out Dragonfly and pc-bsd because he loves ZFS.
OpenBSD zealotry, not the ZFS. Yes. But that's cool. He was able to branch out and try a couple others.
Yeah, he got interested in pc-bsd because he actually wanted to try ZFS after all of our talking about it.
Yeah, we tend to talk it up a lot, probably because it's worthy of it.
It's what I live and breathe now. It's like, actually, in an hour from now, I have a phone call about with IX Systems about buying a bunch of machines to build a high availability pool that can hold 72 terabytes.
Yeah, so just a tiny amount of data, right?
Yeah, only like 36 hard drives in each server.
That's really cool. And ZFS is pretty much the glue that holds all
There'd be no way to
together.
do that with some other operating system.
You'd
have to have some wicked RAID controller that would then try to stitch all those drives into one. It doesn't even make any sense.
No, that just would be a mess. Yeah. But ZFS, I mean, we can't talk it up enough. It just is that cool. So, Noah, I'm glad that was able to pull you out of being a zealot so much on one of the BSDs and go try something else. I mean, that's pretty cool, though. I'm glad you enjoyed ZFS. Very cool. Okay, well, that's the last comment we have this week here. So as usual, we're going to post the tutorial, all the comments, everything in their entirety at bsdnow.tv along with the show script.
Especially this week's tutorial, there's a lot of extra links and more detailed explanations about the different types and even more complex configurations you can get into.
And of course, the legal
Yep.
disclaimers, you'll want to read through those if you're tempted to run an exit node. And, So please check that out. And as usual, send us your questions, comments, any show ideas, topic ideas for tutorials, etc. to feedback@bsdnow.tv. That's the preferred way. We're not going to be monitoring YouTube, JB comments, Reddit. So if you want us to see it, please send it to that address. Although we do monitor our Twitter handle as well. So feel free to send something in Twitter. And as usual, we're here every Wednesday, live, 2 p.m. Eastern Time, 1800 UTC. So if you want to see the whole show in its entirety and hear more friendly banter between Alan and me, that's the place to do it.
There's also IRC chat room if you want to talk with other people while you're watching the show.
Definitely. That's the Jupiter Broadcasting.
Jupiter Broadcasting on irc.geekshed.net. There's also a web-based IRC client directly under the live video stream.
Okay, excellent. So, and we do try and monitor that during the show. So if you have questions or something, we will try and answer the best we can.
Or
so,
as has happened
up
a few times, if you are the developer of the thing we're talking about, you can correct us.
Yes. We'll be like, oh, we got that all wrong. Well, very cool. Well, that pretty much wraps up the show for this week. Anything else you want to add,
Thanks
Alan?
everybody for watching.
Okay, thank you guys for being here and look forward to having you back next week.